Hey guys, in this video I want to go over parallel and perpendicular lines. I'm making this kind of without preparing, so if it's not as comprehensive as I'd like it to be, I might put up another one. So let's first off talk about what parallel and perpendicular lines are. Parallel lines are lines that are never going to intersect. So, you know, a lot of times teachers talk about them like railroad tracks. They're lines that are going to continue to infinity and never cross. Perpendicular are lines that intersect at a very specific way. So when your lines are perpendicular, they will intersect to form a 90-degree angle. And in fact, all four angles at the place where those lines intersect will be a 90-degree angle. Please do not confuse perpendicular lines with just any old intersecting lines. So these lines intersect, but they're not perpendicular. So that's the symbol for perpendicular. I mean, perpendicular is obviously kind of a long word. Oh, let me make sure you can see that. Not perpendicular. I don't know if you can see that over there. So make sure you understand the difference. Don't just like assume that because they intersect they are perpendicular. So these are perpendicular and then these are parallel. Those are the symbols. We also have things when they're the exact same line. So literally you would have like a line like this and you would have the exact same line right on top of it. So we have some things we can talk about with them. For your parallel lines will have the same slope, but they will have a different y-intercept. So in order for them to be parallel, they can't have the same y-intercept because that would mean that they are crossing there, that they're intersecting at the y-intercept if it was the same coordinate. So they have to have the same slope but a different y-intercept. The same line, so these are the same line, they will have the same slope and they will have the same y-intercept. If they intersect, they're just going to have different slopes and they might have the same y-intercept, they might not. So if the place where they intersect is actually on the y-axis, that will make them have the same y-intercept. So we don't care about their y-intercept. It doesn't matter whether it's the same or different. Intersecting lines will have different slopes, but not opposite reciprocal slopes. I know that's kind of weird. Perpendicular, they might have the same y-intercept. It's okay if they have the same y-intercept. But really the only thing we care about with our perpendicular lines is that they have opposite reciprocal slopes. That's like the number one thing we care about. We do not care about the y-intercept. We do not care about the y-intercept of either intersecting lines. The only type of lines we care about the y-intercept for is to tell the difference between whether they're parallel or the same line. So, what is an opposite reciprocal? So, literally those two words are there for a reason. So if you think about the word opposite in mathematics means the opposite sign. So opposite in terms of the sign. Reciprocal has to do with a fraction when the numerator and the denominator switch and become the denominator and the numerator. Like we switch the top. So the denominator becomes the numerator, numerator becomes the denominator. So you have to switch the sign and you have to flip the fraction. So as you continue in math for the rest of your math life, there will be times, especially like Algebra 2 or pre-calc and stuff like that, where you'll use the opposite. You'll use a negative versus a positive. There'll also be times where you use a reciprocal. But the only time in your math life where you use something that is an opposite reciprocal is when you're talking about the slope of perpendicular lines. So if your lines are perpendicular, an example of the slope would be if it's 2 over 5, it's going to become negative 5 over 2. If it's negative 1 over 3, it's going to become positive 3 over 1, which you don't have to write the 1. If it's a slope of 7, it's going to become a slope of negative 1 over 7 if the line is perpendicular. So the other thing that you can tell about an opposite reciprocal is that the product of these numbers, and remember product is the answer you get when you multiply, the product of all of these is going to be negative 1. So if you do 2 over 5 times negative 5 over 2, you get negative 1. Sorry, let me separate this. If you multiply negative 1/3 times 3, you get negative 1. If you multiply 7 times negative 1 over 7, you get negative 1. The only opposite reciprocal that is a little bit tricky, I guess there's two that are a little bit tricky, is just the number 1 and negative 1. It's the only number that kind of is just the opposite because 1 doesn't really have a reciprocal because it's just 1 over 1 or 1 over 1. And you can't tell if you switched the numerator and the denominator because they're the same number. So negative 1 and positive 1 are kind of the exception to where you won't notice that it's the reciprocal because it's a 1 in the denominator anyway. And then the other one that's a little bit tricky is 0 and undefined. Sorry, I missed an E. So undefined is, remember, a vertical line. A vertical line has an undefined slope, and 0 is a horizontal line. So a horizontal line and a vertical line are automatically perpendicular to each other. So all of this opposite reciprocal, that's for perpendicular lines. All right, so let's talk about the types of problems that you'll see whenever you're trying to deal with parallel and perpendicular lines. So if you were asked to compare these lines together to say whether they're parallel, perpendicular, or a lot of times they throw in the word neither, that's tricky. Neither means they're not parallel and they're not perpendicular. But there's two versions of neither. They might just be intersecting lines that aren't perpendicular, or it might just be the exact same line that they wrote in a different form. So let's see what we have here. The number one way to figure out what you have going on is just to check the slope of every single line. So unfortunately, none of these are written in slope-intercept form. So in order for it to be something you can compare, you're going to need to isolate y, unless you have point-slope form like we have down here. So for this one, y is not by itself, so I'm going to have to divide everything by 3. And so I get that my equation is y equals 2/3 x minus 7 over 3. So we know that the slope of this line is 2 over 3. And we only care about the slope unless we end up getting two lines that have the same slope, then we have to check whether they're actually the same line or not. So in this one, let's kind of try to figure out what the slope is by moving everything to the other side. So I'm going to move 10x to the other side, and then I'm going to divide everything by 15. And I can see right here my slope, which is the coefficient of x, is going to be negative 10 over 15. Because this equation is y equals negative 10 over 15x plus 7 over 15. So negative 10 over 15 is really, if I reduce that, the slope would have to be, so make sure you always reduce, the slope of that is going to be negative 2 over 3. So as you compare these guys here, 2 over 3 and negative 2 over 3, they're not the same. So those lines aren't parallel, and they're not perpendicular because they're not opposite reciprocals. They're opposites. This is 2/3 and this is negative 2/3, but it has to be an opposite reciprocal for them to make a 90-degree angle. So these are just going to be neither. They're just going to be intersecting lines. So these first two are just intersecting. not perpendicular. And then this one, you actually don't have to rewrite that because this is in point slope form. In point slope form, the number in front of the parenthesis with the x in it is the slope. The y does have to have a coefficient of 1 though for it to be considered point slope form. So I've seen it sometimes where they actually give you a coefficient of y. It's got like 3y plus 7, and then the rest of it looks like this. That's not point slope form. In point slope form, the y has to have a coefficient of 1. So it does, and we can go ahead and check to see if this is the slope. The x has to have a coefficient of 1 also in order for this to be the slope. So here, my slope is -3/2. So if that slope is -3/2, I mean, these two numbers are simply different. Yeah, that's the reciprocal. It's got a -3/2. This is a -2/3. So we've got a reciprocal going on, not an opposite reciprocal. So we'd have to call these two same thing, intersecting, not perpendicular. However, if you look at this first one and this last one, a slope of 2/3 and then a slope of -3/2, if I multiply those, I get -6/6, which is -1. They are opposite reciprocals, so that means this first one and this last one are going to be perpendicular. So if you suck at algebra and you don't know how to rewrite this equation to get y by itself, this is going to be a really hard problem for you. But you're not struggling with geometry, you're struggling with algebra. So it is kind of tricky in geometry to decide why you're not understanding things. A lot of times it's just that your algebra skills aren't as sharp as they should be. And so, you get stuck because you can't rewrite the equation to figure out what the slope is. But there's a lot of remedy for that. You can go on Khan Academy, you can do the Get Ready for Analytic Geometry, and that should help a lot. They kind of go over isolating the y variable in that. So I would recommend doing that if you feel like you understand the concept of parallel and perpendicular, you understand the concept of how to compare the slopes, you just struggle with actually, moving the numbers to the other side and doing all that kind of stuff. I didn't have an example up there where I had parallel lines, but parallel lines, like I said before, they would have the same slope, different y-intercepts. So in this one, they're asking you to write an equation of a line, and they gave you an original line. So basically, you have to take this line, and the only thing you care about from the original line is the slope. That's it. Do not worry about the y-intercept. Just use the slope. And basically, you're just going to write your new problem the same way you did whenever I gave you 2 points and had you write a linear equation. You had to find the slope. This is even easier because we know the slope. And then you just have to plug in the x and y to solve for b. So that's it. Just take the same slope as long as it's parallel, plug this in, and use this for x and y. So this will be 4 equals 2 times -6 plus b. So that'll be 4 equals -12 plus b. And if you add 12 to both sides, you'll get 16 is your b. So when you write your final answer, you'll say that the answer is y equals 2x plus 16. So that'll be parallel. Now, what they could do is they could change the directions on you, and they could actually say that they want your answer to be perpendicular to the line that they give you. If that's the case, you're still going to use kind of the same process. You just got to fix that slope so that it's a perpendicular slope. So let's pretend that this actually said perpendicular. Remember, the symbol for perpendicular is an upside down T. Upside down T means perpendicular. Perpendicular is symbolized with an upside down T. I say that often because for some reason it's the #1 symbol my students tend to forget. Anyway, so if now I want my equation to be perpendicular to this line, I don't want to use 2 for my slope. I want to use the opposite reciprocal of 2. So I have to change the sign, go from positive to negative, and flip 2, which is really 2 over 1, flip it and make it negative 1 over 2. So now when I plug it in, it'll be 4 equals negative 1/2 times negative 6 plus b. And I can just work it out and solve for b. So in that case, 1 would be b. So this line would be parallel, and the answer to my perpendicular line would be y equals negative 1/2 x plus 1. So the process is that you're going to take the original equation that they gave you and determine its slope. From there, you're either going to use the same slope if it needs to be parallel, or you're going to make it the opposite reciprocal if it needs to be perpendicular. This was a faster video than I usually go through. It might be longer because I put a bunch of stuff in all at once. But let me know if you need me to make like a separate video where I slow down and explain things more in depth. Good luck!